Okay. The degree of freedom. There's only one person. I can wait just a minute, another minute for Metin and Aslo, maybe. There was another lady, I guess, in the first lecture. I'll just wait another minute. It seems no one is coming. Remember to find the critical value T16 and alpha is 0.10 and you divide it by 2, it becomes 0.05. So I will look from the degree of freedom, the row 16, and from the column, I'll pick up alpha level 0.05 single, or I can just pick up two tail 0.10. So to find this value, I'll get you directly to the T table. That's the table using the T distribution, the critical value. The degree of freedom, it tells you that it's 16. And the alpha level of significance, which is 0.05, one tail or two tail is 0.10. So that's the column I will be using. This is the alpha, the degree of freedom. So the critical value is 1.746. 1.746, that's the critical value. Okay, I can go there, write the value, write it down. So this is 1.746. That's the critical value. So this is a double-sided. We have to place one on the left and one on the right. Let me just add you the graphical display of the T distribution. I'll place it here. Yeah, right there. Okay. So I'll ticker and change the color. So I have one here, one on the left and one on the right. Somewhere here. There it is. Okay, we have one on the left, rejection region. So you reject the null hypothesis, reject the null. This is 0.05 level of significance. And this is, we have determined it from the table, minus 1.746. This is from the table. And there it is. I wrote it, so I can write it here directly. And I have another one on the right. And this is 1.746. This is positive. And you reject the null as well. Here on the right side, reject the null. And this is 0.05 level of significance. So the other part, the central part in the graphical display will be, the field will be is 0.90, and you will have a statement here, do not reject the null. Okay. So the calculated statistic is simply, let me draw you. This is the center. The center is 0, and the t-distribution as well. This is 0. And the calculated statistics will be falling within the accept region, the region where you do not reject the null hypothesis. So it will be somewhere here, and you will have yeah, there it is. I'll move this a bit down. Yeah. Okay. So the calculated statistic is 0.2093. So that's the calculated statistic. Is falling within the region where you will not reject the null hypothesis. Okay, since 0.93 is falling within the non-rejection part, the non-area, the null hypothesis is not rejected, cannot be rejected, let's say. Not be rejected with alpha 0.10 level of significance. Okay. So you would end up with this statement. You can also possibly try to, so it means in this example, you will also write a verbal statement telling that the waterfall heights in Europe are not really significantly different from the waterfall heights in Asia. So that's, you can also make this statement as well. So it means the mean waterfall heights mean waterfall height in Europe does not differ from the waterfall, from the mean waterfall, or height in Asia. With 0.10 level of significance. Okay, that's the explanation you can make for this exercise. You can also try to find out the confidence interval for the mean difference. construct the confidence interval for two mean population difference. Construct the confidence interval for mu1 minus mu2 with 90% confidence level. Okay, to do that, let me write you. Yeah, I haven't written the confidence interval yet. I will write you here. I'll give you the definition of the confidence interval, which is x1 bar minus x2 bar minus t n1 plus n2 minus 2, and this is alpha divided by 2 within the square root. I have the pooled variance times reciprocal n1 plus reciprocal n2, and this is square root, yeah, let's equal v1 minus v2 plus equal. I'm gonna copy the lower bound. I'm using it as the upper bound. I'll change something, only a small modification for the upper bound. This is the only change. So this negative sign, I'll change it to positive sign here. Okay, it's down here a bit. I'll move it up there. Yeah, it is. So I'll have this negative, the negative sign, I'll change it to plus. This is what I change here. This is plus, and this one's negative here. I change it. So the upper bound is exactly the same as the lower bound. There is only a single minor difference. So for this example, to construct the confidence interval, everything is known. We know the critical value as well. This one is minus 1.746, and this one too. And x1 bar and x2 bar is already on the screen in Excel. I'll just resize the screen. Yeah, there it is. Okay. I can copy the things here from here. Okay, the lower bound x1 bar is 883. Yeah, it's 883. 883.22, another double two, and minus, this is 840.33, and another double three, minus 1 point, the critical value, 1.746 times the pooled variance, which is 189,019 point something. It was point something. I'll try to, yeah, it is. Okay, fine. 0.1 times 1 divided by 9, and I have another one. 1 divided by 9, close the bracket, let's equal mu1 minus mu2. And this is square root. So I'm going to copy the lower bound up here, E, and then paste it right there. Okay, it is. So I'll have another less equal. Yeah, it is. Okay, the confidence interval, you establish the confidence interval this way. I will change this one into the plus. I'll try to perform this calculation myself. Or you can, if you have a calculator, you can also try to work out this yourself and tell me the lower bound if you have a calculator with you at the moment. If you don't, just watch the lecture and wait for my answer. 883.22 minus 840.3333 and minus 1.746 times within the square root 189,019.1 times reciprocal 9 and reciprocal 9 plus another reciprocal 9. Yeah, I found the lower bound as 300 minus 314.9527. That's equal V1 minus V2. That's equal. And the upper bound is 400.7305. So I'll box it. Yeah. That's the confidence interval. The lower bound is minus 314 and the upper bound is 400 something. So you can tell the interpretation of this confidence interval. We are 90% confident. We are 90% confident to tell that the mean difference between two continents waterfall heights is at least minus 314.9527 and at most at most 400.7305. That's the interpretation of the confidence interval in this exercise. So we can move on to another exercise, try to work out with another exercise. Let me see. Yeah, I can work out with number 2 as well. It's also, this is also a double-sided exercise. I have worked out this with a Turkish section. Tax-exempt properties. A tax collector wishes to see if the mean values of tax-exempt properties are different for two cities. The values of the tax-exempt properties for the two random samples are shown The data are given in millions of dollars. At alpha equals 0.05, is there enough evidence to support the tax collector's claim that the means are different? So let me copy this exercise, place it within my lecture note. There it is. Get to my lecture note, place it here. Yeah. Another example. The one. Okay. Okay, let's write the solution, start the solution from there. Yeah. So once you see the statement that wishes to see if the mean values of the taxation purpose are different. You see the difference? It tells you that this is double-sided also. So I can easily write the null hypothesis. Mu1 equals mu2, and the alternative mu1 is not equal to mu2. Okay, the alpha level of significance this time is given 0.05. So the alpha level is given as 0.05, and N1, it seems that N1 and N2 are identical. Let's count 1, 2, 3, 4, and 1, 2, 3, 4. 4 by 4 is 16, and it's also how you have a 4 columns and 4 rows as well in CDB and CDA. There's no difference. Okay, this is 16 right here. You can easily write 16. The next one, okay, the next thing is you would need to get the x1 bar, and x2 bar. You would need those. Okay, and you will need s1 square and s2 square as well. So I can perform such calculation in Excel also easily. Without losing time, I can do it, perform it easily. So try to copy this page. I'm going to move this. Move it until here. That's it right here. So I'll delete all the stuff here. So I know this is 16. We know the sizes are 16. I will just enter the data set 113, the first sample, and the second one is 25. The next one is 44, and the next one is 31. The next one is 22. The next one is 23, 11, 19, 14, 23, 19, 5, 8, 37. This is 2. Yeah. And completed the first sample. Let me see about the second sample. 82, 295, 12, 20, 11, 50, 68, 16, 5, 12, 81, 4, 15, 9, 2, and 5. Final one is 5. Okay, let me see whether the functions are okay. The main, yes, from B2 to B17, that's correct. Yes, this is C2, C17. This is incorrect. B10 is incorrect. So I need to take until here. It is. So I can use this and the pool variance. Yeah, it's correct. The pool variance is fine, 16, and that's the calculation. So I did everything easily in Excel because I have written the functions in the previous week, like in the the other lecture today from the other lecture. So X1 bar is right there, 24.75. $24.75 million, and the next one is 42.9375 million dollars. S1 square is 674.2, 5,291, 0.796. Okay, fine. I have completed working out with the variances. I can now get the pooled variance from this formula. I'm going to copy this. Yeah. Copy. Place it right here. Yeah, that's the pooled variance. Delete the equality. So the pooled variance would be equal, yeah, N1 minus 1, which is 16 minus 1 times S1 square, which is 674.2 plus 16 minus 1 times 5,291.796 and divided by N1, 16 plus 16 minus 2. So the pooled variance, the result is right there in Excel. It's calculated already there. I don't need to waste time. I can easily write the variance 2,982.9979. Okay, that's the pooled variance. And the calculated statistics, I can also get it from this. Calculated statistics. Copy this. I can perform the calculated statistic within the next page, my lecture note. So this is the calculated statistics. Okay. Okay. Yeah. All right. X1 bar is 24.75 minus. The next one is 42 million. 2.4 million points $93.75. 42.7. Yeah, I have 10 minutes to go to I'll complete this exercise with you. Okay, look, in practice, if you see for both city, the tax exempt, which is for the city A is $24.75 million. And in second, the mean average, the average is $42 million. You can easily tell that there is a significant difference. You can tell verbally, but it's not true. We'll see whether this is enough, if there is enough evidence to tell that this is 24 million is significantly different from 42 million. City A and CDB, whether there is a significant difference. From the mean, sample means, it seems that it's far away. The mean in city A is far away from city B. But let's see formally, statistically, whether this is correct or not. Let's see. Okay, the pooled variance, which is 1,900, no, it's 2,982.9979 times 1 divided by 16 plus 1 divided by another 16, and this is within the square root. Yeah. Okay. The result of this calculation, I have it right there in Excel. This is the value I'm dealing is minus 94 minus 0.9419. The result is 9419. So we need also to bring the critical value, the critical value, which is T N1 plus N2 minus 2 and alpha divided by 2. In our example, T N1 is 16 plus another 16 minus 2. Yeah. And the alpha level is 0.05 divided by 2. That is actually T, the degree of freedom, becomes 30. And the alpha level is 0.025. So I'm going to bring this value, 30, the degree of freedom is 30. So I'll get to the T distribution table, and I can tell easily from T distribution table, look, 30 degree of freedom is 30. And I know there's the alpha level now is 0.025. So I will get from this column, I will use this column, and I'll use this row, just find the intersection is 2.042. That's the critical value. I can easily write it there in the place where I would need. So this is 2.042 from the T table. Okay, if I have the graphical display, I'll have a display also here to show the. I would need to answer this phone call. I'm so sorry. I will. Alo. Ha, merhaba.